Assistant Professor EC Department. Today I am going to start with the next part of the subject, that is data communication network, and the topic of today's lecture is address mapping, error reporting and multicasting. So, these are the contents, that is address mapping. We will see another type of protocol, that is ICMP and IGMP. So, basically we will see its detail, what is ICMP and what is IGMP. So, first we will start with address mapping. What do you mean by address mapping? The delivery of a packet to a host or a router requires two levels of addressing. So, basically there are four types of addresses are there: logical address, physical address, port address and special address. Physical address is device specific, like two computers are connected in a network, then every computer, the both computer will have their own physical address, that is unique. Another type of address is logical address, that is dependent on the connection that has been set up between the transmitter and receiver, from which path it will going to follow, to which particular device it will going to received. Next one is the port address, means which particular devices the device is connected to which particular port. So, that is denoted by port address, and the fourth one is the special address, that is basically dependent on the application you want to access on the receiver's computer. Like in case of OSI model, let us say this is the last layer, application layer at the transmitter side, and this is the application layer at the receiver side, and there are three applications which are running at this point and three applications are running at this point. This is the transmitter side, this is the receiver side. So, these are the application, and it is followed by 7 layers, it is followed by 6 layers actually, because 7th layer is the application layer, and here a transmission medium will be going to connect the transmitter and receiver. So, this is the kind of application, like this computer wants to access this application at the receiver side. So, this has its own specific special address. So, that is the special address. So, in this address mapping we are dealing with the two addresses only, that is the logical and the physical address. We need to be able to map a logical address to its corresponding physical address and vice versa, means physical address has to be mapped to logical and logical address has to be mapped to the physical address. So, this can be done by using the either the static or dynamic mapping. So, in case of address mapping, what we are going to do, we are either considering the static mapping or we are going to consider a dynamic mapping. And what mapping we are doing? We are mapping logical address to physical and physical to logical address. Next one is the ARP operation, that is the automatic repeat request ARP protocol or ARP operation. Then ARP request is broadcast, ARP replies unicast. So, there are two cases, that is request and reply. Whenever you want to access any device which is connected at the receiver side. So, that means it is a request that you have raised to access the particular computer. So, that is the request operation. In response to that request, there is a reply that has been set up, that has been sent to the receiver side. So, that is the case for reply that has been sent from the receiver to transmitter. So, ARP request is broadcast system A, it has been connected to this system B, and there are intermediate operations you can see which has been connected to this intermediate device or intermediate operations that has been generated in between this system A and system B. So, a request has been raised which will be delivered to all the 4 devices that has been connected over here, and whatever request it has been set up, it has to be delivered back to the system A. So, looking for the physical address of a node with IP address, you can see over here that this is a kind of IP address which is 141.23.56.23. So, this is the ARP request is broadcast. Now, next one is the ARP reply, which is unicast. This is system A, this is system B. This has been connected and reply has been set up. So, this is the transmitter part and these are the receivers from where the request has been sent, and when we are talking about the reply will be sent from the receiver side to the transmitter side. So, looking for physical address with the IP address this one. Now, the node physical address is written over here. So, this is when you raise a request, then in that particular request it is not every time mentioned, it is rather it is every time mentioned that what particular operation has to be performed. So, it has to be decided that this one, which particular device has to be work on. So, when we are talking about this ARP reply which is unicast, so the data has to be transferred from this one, and only the physical address of the node, that is of the transmitter, has to be transmitted. So, the node physical address is this one. So, which means this receiver wants to connect to this device which is having this simple physical address, and in case of request it has to search between these devices which has this IP address. So, that is the difference between ARP operation. Next one is encapsulation of the ARP packet. So, you can see over here what is encapsulation. You can see that this is preamble and SFD which is of 8 bytes of information. Now, next one is the destination address which is again 6 bytes of information. This is the source address which is 6 bytes of information. Then type of the packet, that has to be decided that whether it is a request type of packet or whether it is a reply type of packet, and other variations are also there. We will see in the table which has been shown after this slide only. So, this will contains 2 bytes of information. Next one is the data, which is the actual data you want to request to or you want to reply. Then CRC, cyclic redundancy check. So, we have finished many lectures, and you can see, you can if you remember that at the end of every packet there are some, either a flag has been inserted or frame check sequence FCS or CRC that has been added at the end of each frame. What does it mean? It means that we have to check that whether the receiver has received the correct data or not, or a flag that will going to signify that yes, particular frame has been finished. So, that is the concept of CRC and the particular data. So, that is the encapsulation of ARP packet. Encapsulation means how the data has been inserted for the ARP packet in a particular frame format, which consists of this preamble SFD, this is destination address, source address, this is the type of the data that you want to transmit, this is data, and this is the CRC part. Now, next is 4 cases using the ARP. What are the 4 cases that we will see? Like this is a host has a packet to send to another host on the same network. So, this is the host, you can see that this is the, these are the 4 cases. First case, a host wants to send a packet to the send to another host on the same network. So, to connected a single network, that is a LAN, that is a single network, 2 hosts are connected and the communication has to be set up between these 2 hosts. So, this is the target IP address, destination address in the IP datagram. So, this is the first case. Now, second case, a host wants to send a packet to another host on another network, it must first be delivered to a router. So, which what does it mean? Which means that the host is connected to this network, it wants to send the packet to another host which is connected to another network, but these 2 networks are connected to through a router. So, that is the case where this particular data has been transmitted from sender host to the router receiver router, then there will be a receiver which is connected to another host. Then third case is router receives a packet, this is the transmission part, this is the receiving part. A router receives a packet to be sent to a host of another network, it must be first delivered to the appropriate router. So, this is the case third, where again this is the concept which is being used over here. In the fourth case, a router receives a packet to be sent to a host on the same network. So, which means this is the network to which one host and one router is connected. This particular router from the back side, it has received a packet and it has to be delivered to a host or the receiver at the same network, this is the same network. So, this is how the 4 cases are there, 4 possibilities which are possible between the transmitter and receiver, that how these packets will be transferred from this particular device to the another particular device. So, that is the 4 cases. Next one is ARP, request and reply, and ARP request is broadcast and ARP reply is unicast. These are the two important points that you have to remember when you are dealing with ARP packet. If it is a request one, then it will be broadcast. Broadcast means you are requesting for an application, you are requesting for an operation to be made. So, that request will be sent to every receiver, whichever receiver accepts that particular request, it will going to access the data, it will going to transfer the data. Now, next one is an ARP replies unicast. Reply means it will be transferred from the receiver to the transmitter, and in this case it will be transferred from this transmitter to the receiver. In the reply format, it is a unicast, means it is unidirectional, it is one to one, it is from one transmitter, because transmitter is only one. There are more than receivers, more than one receivers are there. So, that will going to that will going to consider the multicast or the broadcast operation, where the single message will be transferred to more than one device. Now, you can see over here that there are two devices are connected, like this one is station A, this is station B. This is a graph that has been drawn with the time. So, this is ARP request that is been made. This is having the header format, you can see over here, this is the request part that has to be transferred to this B device. Now, this is having a physical address of the transmitter to which particular device it has to transmit the data. Then this was the kind of ARP reply that has been sent from the transmitter to the receiver. So, this is the case for ARP request and reply point. Now, next is ICMP. What is ICMP? So far we have discussed the mapping of the logical address with the physical address using two types of modes, that is the request and reply, and using the combination of request and reply frame formats. Now, next we will see ICMP. ICMP full form is Internet Control Message Protocol. The IP protocol has no error reporting or error correction mechanism, which means no FCS or CRC has to be added eventually. So, we will see later. So, there will be no error reporting and error connection mechanism is there, means if any error has occurred at the receiving packet, then it will not going to signify that which particular address is packet is having any error or not. The IP protocol also lacks a mechanism for host and management queries. The Internet Control Message Protocol has been designed to compensate for the above two deficiencies. So, it is a companion to the IP protocol basically. So, in case of this ICMP, this is nothing, it is an IP protocol that has no error reporting or error correcting mechanism. It has a IP protocol which also has both the cases, that is having the lack a mechanism for host and management queries, and it is having this Internet Control Message Protocol, which has designed to compensate for the above deficiencies, that is the companion of the IP protocol. So, this is the ICMP case which has been written over here. Now, next is frame format of the ICMP. What is the frame format of ICMP that we are considering? Like you can see over here that this is type, which is of 8 bits of information, this is code, which is again this is 8 bits of information, this is 8 bits of information which is consisting of this checksum, and 8 bits of information, again this is consisting of the checksum information. Now, this is the rest of the header that has to be added, above the data section. This is the actual data that has to be transferred between the transmitter and the receiver. So, this is the actual data which has to be delivered or transferred between the transmitter and receiver. This is the data section. Then this is the rest of the header that you have to consider between the transmitter and receiver, the rest of the information. Now, this will going to decide that what is the type of the packet. This is the code that we actually want to transmit, which is of 8 bits again. Now, this is checksum, which in combination it will make 16 bits of data. So, that is the frame format of ICMP. So, type, code, checksum, then rest of the header and the data section, which will going to have the actual data which you want to transmit. Now, next is we will heading towards error reporting. There are different types of error reporting, how the error has been reported, is to be reported. So, error reporting is divided into different parts, like first one is the destination unreachable, which is type 3 type of error reporting. Then this is source quench, that is of type 4. This is time exceeded, which is again this is of type 11. This is parameter problems, that is type 12. This is redirection, that is of type 5. So, this is basically the error reporting version. Error reporting means how you have to report the error, which type of error is there, what type of error you want to justify. So, this is the destination unreachable, this is source quench, time exceeded, parameter problems are there, then redirection. So, this is how you have to find out the particular kind of error that has been reported. So, this is the destination one. You want to see that if the destination is unreachable. So, these are the different types of error. If the destination is not reachable by a particular transmitter, so in that case this type 3 error will be generated. If source quench is there, if the source is not providing a particular kind of information, then that is known as source quench. Another is time exceeded. If a particular time is exceeded, after that the data is not being received, then that is known as the time exceeded version. Now, next one is the parameter problem. If the parameter which has to be transmitted between the transmitter and receiver, it has some problems which has been related to this one. So, that is known as parameter problem. Next one is redirection. Redirection means there is a case where if a particular direction has been decided between the transmitter and receiver, and due to some any case that particular path is not going well, then that path has to be changed. So, that is known as the redirection case. So, in that situation type 5 error will be generated. So, that is the case for error reporting. So, different types of errors can be reported. Next one is query messages. So, there are different types of query messages that are possible, like first one is echo request and reply, which means echo has been requested, then a reply has been made for that particular echo. So, that comes under types 8 and 0. Next one is time stamp request and reply. If a particular time has been requested and it has been replied. So, that is the case for type 13 and 14, that is time stamp request and reply. Next one is type 17 and 18, that is address mask request and reply, which means that particular address has been masked, that has to be made requested and it has to be replied. So, that is the case for 17 and 18. Then router solicitation and advertisement. So, if there is two networks are connected through a router, or a host is connected to a network through a router, then router solicitation has to be made and an advertisement has to be set up between the transmitter and receiver. So, that kind of addressing has to be denoted. So, that is a kind of type 10 and 9 cases there. So, that means it has been set up between the transmitter and receiver. So, that is the case. So, these are the different query messages, like in case of this IPv4 version, we have seen that it has a format x point y dot z dot t by n. So, these are the different frame formats are there, type of frame format is there, where this decides the address and this is basically the mask, address mask. So, this is the address mask request and reply case is there. If it is asking for this one to see that what is the starting address of a particular block, then that particular mask will be decided by this one, and this is address mask request and reply. Router solicitation and advertisement is whenever a router is there between the two networks. Next one is timestamp and echo request and reply. Now, next we will see the last part of this lecture, that is IGMP. IGMP full form is Internet Group Management Protocol. The IP protocol can be involved in two types of communication, that is unicasting and multicasting. In case of unicasting, there is a transmitter and a receiver, and it is a one way communication. There is no intermediate node, there is no router or anything exist between the transmitter and receiver. But in case of multicasting, this is another name, its another name is broadcasting, where you just want to send a request for any kind of application, and that request will be transferred to 2 or 3 receivers which are connected to a single network. Let us say this is the network, a bus topology has been used, one computer is connected to this one is connected to this one is connected to this one, and this is the receiver. Fine. So, this request will be sent from this part to this part also, this one also, this one also, whichever computer will going to consider that yes, I am going to access or I am going to follow that particular request, or I am going to fulfill that request, I am going to reply. So, that particular computer is connected to this transmitter, and that will going to transfer a reply in response to this particular network. So, that is the case for multicasting or broadcasting. So, the IGMP is one of the necessary, but not the sufficient protocol that is involved in multicasting. IGMP is a companion to the IP protocol, which means IGMP is alone cannot fulfill all the requirements that has to be fulfilled by the protocols. It has to work in companion with the IP protocol. So, that is the case for IGMP one. Now, IGMP messages, there are different types of messages that are possible with this IGMP protocol that cannot work alone, that has to be work in addition with the IP protocol. So, there will be a general query, there can be a special query, there can be a membership report or a leave report. So, IGMP basically going to deliver 4 types of messages. First one is the general query, any kind of query that has been generated between the transmitter and receiver, it want to transmit. So, that is a general query that will be transferred from the transmitter to the receiver. So, that is a general one. If a special query has been made that I want to take a printout from a particular computer, a particular device, or I want to access some application from a specific device. So, that comes under the specific query. Next one is the membership report. In case of this membership report, it will going to find out that what computers are connected to a particular network topology. So, that is known as a membership report, which has been set up as a part of the IGMP message that will be going to transfer the information to the IGMP one. Means a membership report, that particular receiver is connected to that particular device. Next one is the leave report. If a query has been sent and it has to deliver to a particular data to a particular receiver, then sometimes it is possible that the receiver is not able to fulfill that request, fulfill that particular query. Then in that case a leave report will be sent from the receiver side to the transmitter side. So, that is the case for IGMP message. So, these are the references that you can go through for all the 3 topics, that is address mapping, in which we have mapped the logical address with the physical address of the individual device. Secondly, we have discussed about ICMP, and thirdly we have discussed about IGMP, that cannot work alone, it has to be work with the internet protocol, and these are the references. Thank you.